Again, thank you for stopping by our YouTube channel. And in this series of short videos, we'll walk through Istio's certificate authority handling of certificates, rotation, and minimizing downtime for these types of events. My name is Christian Posta. I'm writing the Istio in Action book. I have been contributing to and involved with the Istio community for the last 3 years or so, 3.5, and I now work for solo.io. So in this demo, what we're going to look at is rotating or reinitializing Istio with a user-provided root CA chain. And we want to do this because by default, Istio will create its own CA. And we'll use that to assign the workloads. Typically, organizations already have PKI and their own roots, and they want to derive the workload certificates from that so that other parts of the organization can share in this trust model. So to do that, what we're going to do is look at the cert chains that I've already set up for the duration of these videos. We have 2 roots, and that will become apparent in the 3rd and 4th videos, but not yet. We're going to focus on a root certificate called root A. And this root has been used to sign an intermediate certificate, intermediate root A. And it's this intermediate that we will use to sign further certificates, including Istio's workload leaf certificates that get used for mutual TLS and identity. All right. We also have a second intermediate CA that has also been signed by root A. And then we have a totally different intermediate CA signed by root B. And so we'll see this in the progression of the videos here. So the first thing that we're going to do is we're going to demo creating our own or telling Istio to use our own certificates, not its own self-signed Istio generated ones. The first thing that we're going to do is we're going to take a look at, this is the self-signed user or Istio generated root CA that comes with Istio. Let's look at connecting to an HTTP bin service from a sleep pod. So from sleep, we'll log in, call HTTP bin, everything works fine. We can see through the headers that there are cert chains being propagated, and indeed we're being used for mutual TLS. Let's see exactly what that certificate chain is and what root is being used. So if we come back here and look at the chain, we see a leaf node, that leaf certificate, and we also see the root certificate here, and that ends in STY. You should see that matches what we expected. So everything's functioning fine here. Let's update Istio to use a CA that can be used to sign these workload certificates that derive from a root that we own, not that was generated by Istio. So the first thing we're going to do is create a secret called CA certs. CA certs is the magic secret that Istio will look for at startup time, and startup time only, at least at this point. And if it exists, we'll use that to generate its certificates for the rest of the system. And we can see we are going to provide the intermediate that has been signed by root A. So we created the secret. Let's restart Istiod. Let's go to K9s. Let's come the Istio system, we should see that it had been restarted. And it looks fine. Now what we're going to do is we're going to take a look at the logs in Istiod and make sure that indeed we are using our own CA certificate that we just created. Alternatively, you would see the actual root CA spit that gets spit out here in the logs if it was automatically generated by Istio, but we don't see that. So that's all very good. Now, if we take a look at the proxies themselves, we start to see some trouble because the workloads originally were provisioned with the Istio generated root and then signed by that root. Now we've introduced a new one. And so the tooling that we would expect to show and connect to the different components in Istio are not working. Furthermore, what happens between the services? Let's say we delete the HTTP bin pod. And we're going to do that because we want the HTTP bin pod to pick up the new certificates and signed by the new root that we just introduced. Now, if we go into, actually we can take a look at the logs here. So if we go into sleep, let's go into the sleep pod, take a look at the logs. Now, if we call HTTP bin from sleep, we'll notice that it doesn't work. And that's because the roots have changed. And this is a problem. If you're expecting mutual TLS in the system and you change the roots, you will see that the connections don't work anymore. If we come back into our logs here and try to find that one specific connection that failed, we should see that it failed because the certificate could not be verified. The roots on either of these two workloads, or rather the certificates that have been used, are anchored in different roots, and they don't match up and they're not trusted. So step number one here is let's go ahead and get everything onto, let's restart it. So we're restarting the sleep pod, and we should see that come up successfully. And now when we make the call between sleep and HTTP bin, we should all be on the new root CA that we introduced, and the call should succeed. So this leads to the obvious point of, well, 2 points. If you change the roots, let's actually run this. If you change the roots and they don't match up, and the different trust stores don't match up for the different workloads, you're going to have downtime. The second thing, if you live in an environment where you have existing PKI, use Istio with that PKI. Don't use the self-signed certificates. In the next video, we're going to take a look at what happens when you start rotating these certs, like we just did, between the workloads. And then we're going to show you how to do this in a way that doesn't disrupt traffic, even if you have to change the root CA itself. So in this demo, we showed you change the root CA, you're going to have interrupted traffic, but we'll look at approaches for not having that interrupted traffic. Stay tuned to the next video.